Hello students, welcome to the 10th video lecture of Digital System Design subject. In the 9th video lecture, we discussed about BCD addition. Today, we will learn about the concept of binary multiplier. The multiplication of binary number is performed in the same way as for decimal numbers, but the addition is performed as per binary addition. Let me take example of 2-bit by 2-bit binary multiplier, where 2-bit binary numbers are A1, A0 and B1, B0, where A0 and V0 are the LSB of given number. This is the process how the multiplication of 2-bit binary number can be done. We have two number B0, B1, A0, A1, and after doing multiplication, the output in the form of C0, C1, C2, C3 will be produced, where C0 is representing the LSB and C3 is representing MSB. Here is the logic circuit of binary multiplier. With this, we can multiply any 2-bit binary number. So before starting, let me number the given logic gates. Let this is logic gate number 1. This is AND gate basically. This is logic gate number 2. This is logic gate number 3 and this is logic gate number 4. Please understand all 4 are AND gate, and also in the circuit half adder is given. So let this is half adder number 1 and this is half adder number 2. Also, let me take the input value which we want to multiply. Let B0, B1 is 1, 1 and A0, A1 is 0, 1. So we can say that we are going to multiply 1, 1 with 1, 0. So 1, 1 is basically 3 in decimal and 1, 0 is basically 2 in decimal. So after the multiplication, our answer should be 6, or in binary we can say that our answer should be 1, 1, 0. Fine. So let's start the multiplication. As you can see that A0 value is 0 and it is moving with this direction and it is reaching to this particular end of AND gate number 1. Here, as you can see that for AND gate number 1, we have two inputs 0 and 1. So it will produce 0 as an output. So you will get C0 as a 0. For AND gate number 2, the inputs are 0 and 1. So it will produce output 0, which is fed to one of the input terminal of half adder. Now let's come towards AND gate number 3, where B0 and B0 we already have assumed B0 as a 1. Now from this direction A1 is coming and A1 has already assumed like 1. So at the input terminal of AND gate number 3 we have inputs 1, 1, so that it will produce output 1. And as you can see that half adder number 1 having two inputs 1 and 0. So this half adder will give answer 1 and it will produce 0 carry. This 0 carry will be fed to half adder 2. Let's come towards AND gate number 4. For AND gate number 4, we have two inputs B1. B1 is already 1, which is assumed, and A1 is also 1, which is assumed. So at the input terminal of AND gate number 4, we have 1, 1. After doing multiplication, it will give you 1 as an output, which will be fed to half adder number 2. Now half adder number 2 having two inputs 1, 0, so that it will produce 1 as an output. 1 as an output. Now half adder number 2 will not produce any kind of carry. That means we can say that there is no carry. So here, as we can see that C0 value is 0, C1 value is 1, and C2 value is 1, and C3 value is 0. So ultimately what will be our answer? Our answer will be 0, 1, 1, 0, which was required at the beginning. So this is the concept of working principle of binary multiplier. Instead of taking 1, 1 and 1, 0, we can change, or we can take any 2-bit binary number for multiplication, and this circuit can perform any 2-bit binary number multiplication. Thank you.